with that. So with the argon gas mix, you need to have this on your nozzle because the air is coming out there and you need to guide the air onto that. Flux core is different. The flux is inside there. Can you see it?
Inside the wire? Or,
inside the wire. So what they do is they take the flux like with the welding rod outside, they put the flux and they coat it with wire around it. You can feel the wire is different from the other one. So there are two things. Flux core, there's no gas. So technically I don't need to have this because there's no gas coming out. So I can weld with it as it is like that.
If you weld it,
but the problem is this is, well, it's one because I'll explain that now. So, and the reason why is the other thing you're doing now is like a welding rod. It's coming out here, it's making contact and it's welding. So it's just like a normal welding rod. Two things that you need to know is that it's supposed to be a positive or a reverse polarity. All welding machines are negatively earthed. So your torch is positive and your earth is negative. This one is around, so if I turn it around, so this one now becomes positive and this one is a negative. So why would we reverse polarity in any machine? Because I do that with aluminium as well. You'll see on the, they say you have to do reverse polarity. Even in the learner guide that you've just done, it shows you reverse polarity. So why would we do reverse polarity?
I think it's to change the current so that the current won't be too high.
No, the current you set here. So whether it's negative through to positive or positive to negative, the current flow is the same. Well, why would we do positive?
Isn't it because it's a change of material?
No,
the material is the same material.
Same material. So let me just explain. If I'm welding with a welding rod, just give me a normal welding rod. Just give me one. So what I want to do is just hold that for me. So in a normal welding rod, if I clamp my holder here, so I already said this is now positive and this is negative. So what is happening now, current electron flow goes from negative to positive. So what you're doing is you're heating up your material first and then the rod, it melts. Reverse polarity, I change it around. Now the current is heating up the rod and then the material. So the focus is now not heating your material, but heating your rod. So the reversing polarity, you'll see in the drawing, the flow of the current changes and it's where the heat concentration is. Is the heat concentration in the rod or is the heat concentration in your mother material? Alright, so for flux core, the second thing is, first of all, it should be positive. So we haven't tested this machine, so I don't know whether we were struggling the other day with that. Current setting is the same. So wire speed and current flow are the two things that you need to do. But this one takes a special flux core tip. The tip that I bought yesterday, and now you'll see that this tip is longer than the normal tip.
The multi-tip is mostly short.
The normal one is shorter tip. And the reason for that, the shorter tips need to have the gas with it. And when the wire comes out, you mix the gas and the wire and the electrical short. This one, there's no need for that. So you're going to stick, we call it the stick out is further. It's positive, so we're going to heat up this one first. So this one is going to get all the heat. So what is important about flux core welding is that your stick out is about 20 millimeters, 10 to 20 millimeters, because you need a fairly long stick out. Why that long? In normal one, you'll go for a shorter one like that. Now this one we're making longer. And the reason why they say is that you first want to heat up the flux and then melt. So you've got like a longer stick out that you need to run.
So it gives it a longer time to heat up.
Not a longer time, it's thin wire, but it gives you, if it's like short there, all the heat and all it's concentrated. But if I do it like that, so now I've got a longer space to heat up my wire. And that means the flux is ready and I can weld. All the other techniques the same, except the rule. What's the rule I gave you yesterday?
The roof. The reckon.
Huh?
The reckons.
Drag, slag.
If there's slag, you drag.
Yes.
This one has got slag. The other one doesn't have slag. It just got gas. There's no. This one has got slag, so you have to drag.
So you have to drag. Okay.
So it's
So the
exactly,
other one you have to.
yeah.
Okay.
Other than that, PPE. So we're going to switch on the machine and we're going to try. I can tell you it's not going to be